Is Mars our only hope of identifying 3i Atlas? What's the relationship between the interstellar visitor and the red planet? Comet 3i Atlas, our newest interstellar guest and only the third of its kind, is currently a total pain to observe. But why? That's because it's on the opposite side of the solar system. The sun's glare makes seeing that dim little comet nearly impossible. But the only good thing is that Mars is also in that distant neighborhood, which means our spacecraft orbiting and rolling around the red planet are basically giving us a cheat sheet, snapping exclusive photos of this visitor from another star system. And who gave us this footage? The European Space Agency. They released the images captured by their spacecraft, the ExoMars Trace Gas Orbiter, right as the comet made its close pass by Mars. Now this is where it gets really interesting. The orbiter's camera is absolutely not designed for this. It's built to stare straight down at the Martian surface, only about 250 miles below. Normally, it snaps pictures 3 times a second with lightning-fast exposures. But for this comet, they had to completely re-aim the camera at a tiny speck nearly 20 million miles away using exposures 5 seconds long. They were trying to capture an object up to 100,000 times dimmer than anything they usually look at. So, did it actually work? What they saw left the team speechless. The fact that they successfully caught the comet's bright dot moving among the distant stars is a seriously mind-blowing achievement. But why 5 seconds specifically? That was their perfect moment, just long enough to collect a faint light, but not so long that the comet's rapid motion would smear the image into an unrecognizable blur. And they didn't just take a single image, they shot images through red, near-infrared, and blue filters. So, if the light coming off the comet is bluer further away from the nucleus, that suggests the particles are getting smaller. But why does blue mean smaller? That's because smaller particles are much better at scattering blue light as the ice turns into vapor. If they don't see that blue shift, it likely means that there's little or no ice left and the particles are roughly maintaining their original size. One key scientific question still needs to be answered. Is the ice turning to vapor? The scientists have the images, but they're not ready to make their grand announcement yet. They still need to carefully analyze the data to reach any confident conclusions. You see, while the color filters are necessary for science, they also block a lot of light, making it tricky to find a genuine scientific signal without confusing it with random sensor noise. It's basically like trying to pick out a whisper in a crowded room. Not impossible, but pretty hard. And for the sake of backup, another much older European spacecraft, the Mars Express, which has been orbiting Mars for over 2 decades, also tried to snap pictures. Unfortunately, its camera makes out at a half-second exposure time. That just wasn't long enough to capture this elusive object. So, in the images taken between October 1st and 7th, nothing happened. It was just empty space. In the end, these new images from the Trace Gas Orbiter don't suddenly rewrite the astronomy textbooks. Their real value is that they're data points. They add to a bigger file that will eventually let us fully understand how a comet born in another star system behaves compared to the ones that just swing around our sun. The 2 most important check marks are, was the comet where they predicted it would be? And was it as bright as they expected? In both cases, we can breathe a sigh of relief. The answer is a solid, resounding yes. Amateurs going through the raw images taken by NASA's Perseverance on the surface of Mars think they've actually spotted the comet's streak. The only problem is that due to the US government being partially closed, that image hasn't been officially confirmed or released by the agency, so we're stuck waiting for the final word. This massive object is actually the 3rd one we've seen coming from another star. The first was named Oumuamua back in 2017, and the second was Borisov in 2019. Every time one of these alien objects shows up, people get really excited and start asking the same questions. Could this be an alien spaceship? Are they just flying by? Or are they here to deliver some kind of message to us? This whole idea isn't just some random dreaming act. A lot of it comes from an amazing book written in 1973 by Arthur C. Clarke called Rendezvous with Rama. Now, in this story, astronauts chase down a huge alien ship that's on a similar path, trying to find out what's inside. But so far, there's no proof of any of that. This object doesn't look metallic when light hits it, and we haven't picked up any radio signals from it either. Plus, it's surrounded by a pretty huge cloud of ice and dust, which a regular spaceship probably wouldn't have, unless it was trying to hide from us all, of course. What makes this visitor so special? Honestly, most of 3i Atlas's behavior is totally normal, acting just like our own sunbound comets. But its one signature difference is speed. This thing's fast. It's currently tearing through our solar system at a staggering 130,000 miles per hour. That's not just fast, it's the highest velocity ever recorded for any object simply passing through our cosmic neck of the woods. Before we go deeper, make sure to like this video and subscribe now so you don't miss the next data drop. Our new interstellar guest will make its closest approach to the Sun, a point called perihelion, in October. To put that distance into perspective, it'll be about 2 astronomical units, or twice as far from the Sun as Earth is. Even then, it's still gonna be moving fast. This incredible speed is the final definitive clue to its nature. It has to be moving that fast, a truly blistering pace, because it needs the energy to break free from the Sun's massive gravitational pull. If it were any slower, it would get stuck in our solar system forever. So where exactly did 3I Atlas come from? Well, we know it entered our system from the direction of Sagittarius, which is right where the center of our entire Milky Way galaxy lies. But there are billions of stars in that direction. Pinpointing the single star system this comet was born in is like trying to find one specific grain of sand on one specific beach. But scientists love a challenge. A team in Spain has carefully traced the comet's path backwards for 10 million years. They were looking for one of two things: the actual birth star of this object, or any other star whose gravity might have influenced its journey on its long trip to us. The core of this investigation relied on data from the Gaia Space Observatory, which spent 12 years mapping the positions and motions of billions of stars in our galaxy. Using this massive stellar directory, the astronomers traced 3I Atlas's path way out to over 100 million astronomical units from our solar system. That's a huge distance. Their detailed calculations identified 93 potential close calls or encounters the comet had over its 10 million year journey. Out of those 93, 62 were deemed significant enough to pay attention to. Surprisingly, none of those encounters produced any meaningful change in the comet's orbit. In simpler terms, even the significant stars zipped past 3I Atlas too quickly and were too far away to truly affect the comet's path. So, after all that work, the team couldn't find a single star that was responsible for delivering this third known interstellar object right to our doorstep. The search for its birth star continues. But based on the comet's unique up and down weaving motion through the galaxy, the research team made a huge conclusion. They now believe this object most likely came from the Milky Way's thin disk, which is generally home to younger stars, rather than the older, thicker part of the galaxy as previously thought. However, even if it came from the younger area, it could still be an ancient artifact, ejected from a stable, long-lived system that formed very early in the universe. The bottom line is that identifying where these objects come from, where 3I Atlas was truly born, is the master key to unlocking some pretty huge galactic secrets. But it does leave us wondering, if we still don't know where it came from, will we ever truly know where we came from? Let us know what you think in the comments section down below.